Hello guys, I'm Kristen, and I'm going to do the exam 2 portion of the test. Okay, so for question number 1, it talks about an autosomal disease that affects 1 in 750 individuals in the population. And so for the first part of the question, part A, asks what the frequency of the non-disease allele in the human population is. So here, I just subtracted 1 from 750 to get the p-squared value, which is going to be the dominant genotype. But in order to get the allele frequency, you have to take the square root of that to get your p-value, which is going to be 0.9993. Okay, for part B, it asks for the frequency of the disease allele in the population. And since we know that p plus q equals 1, you can just do 1 minus the p-value from part A to get 0.0007. For part C, it asks what the frequency of the heterozygous individuals in the population are, and all you have to do for that is 2pq. So take the p-values and the q-values from part A and B, multiply those together, times it by 2, and then that'll give you 0.0013. And then for part D, it says, out of a population of 1 million people, how many heterozygotes are expected? And all you have to do for that one is take the value from part C and multiply that by 1 million, and you'll get 1,300 people. All right. So for number 2, part A, it indicates several letters and asks you which is which. So for part A, it asks what W is represents, and that's the phosphate groups. X is represented by the deoxyribose group, and we know it's deoxyribose because there's thymines, which are only present in DNA, not in RNA. In the Y portion, it is indicating thymine, and that will be a pyrimidine. And then for letter Z, it's indicating a nitrogenous base, possibly a purine. Part B, it says indicate the 5' and the 3' end of the DNA strand on the image above. So here is the 5' end, which is attached, which is going to be started by the phosphate groups here, going down 3', and then the 3' end here is going to just have the sugar sticking out and going down to the 5' end, and these are going to be anti-parallel. And then for part C, it says to indicate backbone, and the backbone is going to be composed of the sugars and the phosphate groups. So the backbones are the ones on the outside. And then for part D, it says to indicate the portion of the molecule that gives the DNA its negative charge, which is going to be the phosphates again. Okay, so for question number 3, it's asking about Drosophila fruit flies, and you're asked to determine the allele arrangement for part A. So for the first portion of this question, I just wrote out the recessive alleles and what the phenotypes are going to look like, and then the wild types, which are always going to be a dominant. And then, so for part A, we see that the female is going to be heterozygous, as always, and the male is going to be homozygous recessive. And then for that, in order to figure out the heterozygous parent, you're going to take the 2 most numerous crosses in the table given, which was 17 1773 and 1761, and that turned out to be this type here. And then for part B, it asks to determine the gene order. So here we're going to do the different orders that they could be in, and in order to figure out which one is the correct one, we're going to do our double crosses, and we have to look at the lowest number of crosses, which will give us double crosses in the table given. So it was 6 and 8, and we find out that the correct gene order is going to be this one here in the middle. And then for part C, it's going to ask us to construct a linkage map to show the map distances. So in order to do this, we're going to have to take this and do this, the heterozygous female gene order, and you're going to have to do the single crossovers in order to find the correct numbers. So here I did the single crossovers along with the double crossovers, and then the map looks like this, and we have 5MU and 7MU. You can see that here. And then for part 4, it asks to calculate the inference. And to calculate the inference, you're going to have to take the distance, divide them by 20, multiply the two together, which is right here. Multiply it by 100 to get the percent. And then you're going to find the total number of crossovers and multiply that by this percentage up here. And that'll give you 1,400 observed double crossovers. And then we have to go back and see that we only had 6 and 8 for our double crossovers, which gives us a total of 14, which is the actual number of crossovers. So in order to get the inference, you have to take 1 minus the actual number of crossovers over the total number, which is going to give us 0.99, and then that gives us a 99% inference. And for question number 4, we have a Hardy-Weinberg equation, and it says that this specific disease affects 1 in 32,000 people. So for part A, it asks what the frequency of the D allele is. And since we know the Q squared, which by the way, the D allele is going to be our Q value, we know the Q squared value is 1 over 32,000. So from that, we can take the square root of that and get our Q value, which will be 0.0056. And that's what the frequency of the D allele is, which will be our P value. And like before, you can just take 1 minus our Q value, because P plus Q equals 1, and you will get 0.9944. And then for part C, it asks what the frequency of the homozygous dominant genotype is, DD, which will be our P squared value, which we'll take this P value from part B and just square that to get 0.9889. And then for part D, it asks what the frequency of the heterozygous genotype D, capital D, lowercase d is, which will be our 2PQ value, and that will be 2 times our A and B values, which will give us 0.0111. And that is all. Thank you for watching.